Welcome back to Let Us Learn to Lead video series on free open source software prepared by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to verify the results on equal chords of a circle. To prepare this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be preparing. We will try to verify all the results on equal chord and equal arc also in a same worksheet. We will tell them that chords which are equal in length subtend equal angles at the center of the circle. We will take a circle, we will take a chord, and we will take another equal chord, and we will tell them that these are all equal chords. Let us try to explore property one after the other. Okay, first one is the chords which are equal in length subtend equal angles at the center of the circle. Therefore, they can come and verify it. The angles are equal. Then they are equidistant from the center. Therefore, we will show them the distance also by moving it. They can check whether they are always equal distance from the center. Then there is one result on arc. If the chord are equal, the arc are congruent. When the arc are congruent, the chords are equal. Both part of that result can be verified over here. Therefore, the length of the chords are equal. Then if the congruent arc subtend equal angle, that also can be verified by checking these two chords are equal, the arcs are equal, they are subtending equal angles. Therefore, the result and the converse of the result also can be verified by using this dynamic worksheet. Let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet and I have taken geometry view, and in option I have taken rounding off to one decimal place and labeling of new points only. As usual, we will go for heading. I already typed the heading, equal chords of a circle. Good. We will type it. And first we will draw two equal chords. Then we will start exploring the results. And we will tell the children that every result is having the converse also. The child can come and verify the converse of that theorem or the converse of whatever the result you are mentioning over here. Okay, now always it is advisable to go for a circle of different radii. For that, let me go for integer values and 1 to 10 with increment 1. I am taking one slider over here. It is actually not required. You can take a single circle and you can prove it. But if you change the radius of the circle and then explain it to the children that if I change the radius, actually what happens, whether is there any change in the chord and all, you can explore it with the children. Okay, well, now let us go for this circle with the center and radius. I will put it over here. I will call the radius as small n. Okay, now when I move it, this also moves. Well, now normally the center will be taken as O, therefore you can rename it as O because GeoGebra takes it as capital A in the beginning. Okay, now let us go for getting equal chords. Let us may take one point A and a point B by taking it point on the object. It is always advisable to go to point on the object and then put it. Otherwise, there is a chance that that point may go away from this particular circle also. Okay, now let us go for drawing one segment. But we got one segment as AB. We want to draw one segment equal in length. Therefore, we will use the idea that we will try to draw one rectangle or a square inside this so that the opposite sides will be automatically equal. For that, let me go for a perpendicular line. I will draw a perpendicular line to this through B and again for this AB through this C. Okay. Now let me go for point of intersection. Okay, D has come. Okay, we will change it afterwards. We can change it as rename it as C. Okay, because we want it to be in order. Okay, now we will do it, no issues. Okay, now let us go for drawing one parallel line now. Go for this line, parallel line for this through this C. Okay, anyway, it already cuts. We are just checking it. Meeting point of these two. Okay, you can make this CD, escape. Okay, now we can make use of this segment now, and this segment DC is also drawn. Okay, we got two cards now. But we will go and show the object. This is not required. Show the object, it is not required, and show the object, it is not required. Okay, now we got two cards now. We have to tell the children that these are all actually equal. Now the C1 is one more because we have drawn that line, therefore it is coming. Therefore if you don't want to show it to the children, the C1 can be drawn white, therefore it goes. Okay, now it is left to you. You can make this as a D, D1 and so on as per your convenience. Suppose this is D, this is C. Anyway, okay, now we have to tell that these two are equal cards. Therefore, right click it. It is of segment F. Go to the object property and then try to show its value. That is the length of it. Okay, 6.5. Similarly, click it. I think is it DC selected? Yes. Show that and then go to the value. It is also showing it as 6.5 and it is also showing 6.5. Okay, therefore now you can declare to the children that AB is equal to CD is equal to, I think you know that the length is from the object property, it is small f, okay, are equal cards, are equal cards of a of the circle. Now you can go on asking the children that when there are equal cards, what will happen one after the other. Therefore, let us go for property number 1. They subtend equal angles at the center. We will go for it. We will declare it and then we go for it. What is the meaning of subtending equal angles? For that, we have to go for this segment. Go for segment OA, segment OB, then segment OC, and segment OD. Now let us try to show the angles now that go in clockwise direction, A, O and B. Similarly here also you have to go in clockwise direction, C, O and D. Got it, I think. Both the angles, and you can pull it and then push it in a particular spot and then show it to the children. Can make it a little bit big. Okay. Now these two angles are equal. Therefore you can declare that from the symbol you can go for this angle symbol. Angle symbol is over here. You can tell the children that if you go in anti-clockwise direction, angle BOA is equal to the angle when you go in that anti-clockwise direction, the next angle DOC, okay, is equal to. Now you can go to the object properties and you can put it over here, alpha is equal. Okay, now you can ask the children to come and push it and pull it. Suppose if they are pulling it and pushing it and then making the length of this cord at so many places, it is equal, but now it is now subtending equal angle at the center. Once again, a child can ask the next property, equal chords are equidistant from the center. For another property, now we got it. We will try to verify that property now. Okay, in the previous property, now you can have the converse of it also. Suppose if the angles subtended are equal, the chords are equal. Okay, now a child can verify both the result and it converts also. Okay, the equal chords are equidistant from the center. For that, I will go for this perpendicular line and I will draw one perpendicular line to this through this O. Okay, now it is meeting at 2 points. Let us go and find the point of intersection of this line and this chord, and this chord and this line. Good, you got it now. Okay, now I will pull this 8.5 over here and I will put this 8.5 over here. Now I want two segments now. The segments are OF and OE. So many segments are here. Therefore, what we can go for this graphing and check out what is the name given to it by GeoGebra. It is 2.7, 2.7. Or go to the right click, go to the object property. You can have a color to it and you can little bit make it thick. And in the basic, you can go and you can show its value. Okay. Again, you can touch this, the next one. Yes, okay, Y is selected. Again, you can go for its color and you can go for its style. You can have a little bit thickness, and in basic you can ask it to show its value. Good. Okay, now you can know that this is R and S, that you have to remember in mind. Okay, now you can come back to this geometry. It is being done only to do it very quickly. Therefore, now in the ABC, you can tell the children that OE is equal to OF is equal to, I think both are R and S, therefore R. Either you can take R or you can take S. Okay, well. Now you can ask the children to come and check it out. You see always 3.3, 3.4, 2 point. Okay, now it is always the distance is same from the center. Now you can go to the converse of this result also. If they are equidistant, the chords are equal. If the chords are equal, they are equidistant. If it is equidistant, then the chords are equal. Fantastic. Both the results can be checked by the student. Now there is one more result on the arc. Suppose if the chords are equal, the arcs are congruent. Okay, that we can declare, and we will try to find it now. It is also very simple. Now we have to go for the chord. For that, go to this circle. In that there is one circular arc is there. Now touch this O, touch this A, touch this B. Now you got this arc now. Escape, right click it. Now you got this arc. Go to the object property. In that style you can make it little bit thickness, 9 points. And in the color you can have it as little bit green. Okay, you got it now. Now in the basic you can go and have its value. Value means 9.2. Okay, now let us go to the other arc also. There is arc of the other equal chord. For that again go to the circle, go to the circular arc. Again repeat, I repeat, you have to go in anti-clockwise direction. Therefore you have to go in this direction. For touch this O, touch this C, touch this D. Okay, I think you got it. Okay, right click it. Okay, OCD. Go to the object property once again. Go to the style, thickness you put 9 points. In the color, use the same color as you used in the previous one, so that because both are equal. Now in the basic, you can go and show the value of it. Okay, it is also showing 9.2. Now you can ask the children to come and verify it by pulling and pushing. They can pull it, you see. The same thing, 8.3, 8.5 like that. Okay, now you can declare it over here. Therefore, the length of arc, okay, OAB is equal to length of arc OCD is equal to. Now you can tell from the object property. I think we will find out what is it actually. When you right click it, it is a D. Therefore, from the object property, you take this D. Okay, I think you got it. 9.9. Now you can ask the children to come and pull it and push it. All the properties are over. Okay, one more property, that is the converse of the result which the child has just now verified. That is, if the arcs are congruent, then they subtend equal angle. Therefore, these two arcs are congruent, but angle subtended by them is 110.7. Therefore, by making use of a single worksheet, you have verified all the properties of equal chords. If the chords are equal, then the arcs are congruent. When the arcs are congruent, the chords are equal. When the chords are equal, the distance from the center is equal. If the distance from center is equal, then the chords are equal. And about the congruent arc also, they subtend equal angle. For everything can be verified by a child in a single worksheet. Now already I told you that always go and activate this navigation bar, so that by coming back to the step number 1, step by step you can tell the children, okay, these are all the chords. Now you can ask the children that if the chords are equal, actually tell me, list out the properties. Property number 1, property number 2, property number 3. After every property you can stop and then check it and then come back and then ask the children to verify. It's a very interactive way of explaining all the results on equal chords of a circle and equal arcs of a circle. And not only that, you can check the converse of the result also. Thank you. Let us learn to lead.